Hello everyone. In this session we'll discuss a question on Poisson distribution. So let's see this question on Poisson distribution, as we have already discussed the concept and the formula required for Poisson distribution. The question says, if the probability of producing a defective screw is P equal to 0.01, what is the probability that a lot of 100 screws will contain more than 2 defective screw. So in this case, the rate, we have to find the defective screw. So the rate of finding a defective screw is given as 0.01. So that is the rate of success. So I'll say P equal to 0.01 and number of screw given is 100, that is the lot, and we need more than 2, so X should be more than 2. We can see that rate of success is very small and the number of screws or number of things present are very large. So instead of using binomial, we'll be using Poisson distribution, and the mean value will be given as NP, which is 100 into 0.01, which is 1, and this will also be equal to lambda. Now x greater than 2 means what? It can take values like 3, 4, 5, 6 and so on. Like we have 100, so up to 100. So 100 is a very large value. So now, in order to find the probability of x greater than 2, we'll have to add all the values for x equal to 3, x is equal to 4 and so on. And what are the values we are not going to take? What are the possible values of x? The possible values of x are x belongs to 0, 1, 2, 3 and so on, of which x greater than 2 means 3, 4, 5, 6 and so on. So what are we excluding? We are excluding 0, 1 and 2. So this means that this probability can also be written as 1 minus probability of x less than equal to 2, which is 1 minus probability of 0 plus probability that x is equal to 1 and probability that x is equal to 2. And we know the expression for density function, that is f of x is equal to e to the power minus lambda to the power of x by x factorial. So this is x equal to 0, equal to 1, equal to 2. So this value becomes, or 1 minus, so what is the value of mu here? Mu or lambda is 1, and of course we will have this e to the power minus lambda, which is a constant in all the expressions. So I'm taking this common and we can write lambda, which is 1, so 1 to the power 0 by 0 factorial, 1 to the power of 1 by 1 factorial and 1 to the power of 2 by 2 factorial. This will be 1 this will be 1 by 1, this will be 1 by 2, so this is 2.5. So this is nothing but 1 minus 2.5 times of e to the power of minus 1, which is 0.0803. What if the next part says we need to find, like in this case it was will contain more than 2 defective. So let's say will contain at least 2 defective screw. Now at least 2 means x is going to be greater than equal to 2. That means this probability is going to be 1 minus probability of x less than 2, or 1 minus probability of 0 plus probability of 1. We have already found this value. This is 1 minus e to the power of minus 1, 1 plus 1. This is nothing but 0.264. And what if we want it will contain less than 2 defective items? So this means x should be less than 2. So for p x less than 2, this is 1 minus this will simply be p of 0 plus p of 1, and we know that this is nothing but e to the power minus 1, 1 plus 1, which is 0.7357. Let's see one more part. Let's say D is will contain at most 2 defective screws. That is, x is less than equal to 2. So this probability is probability of 0 plus 1 plus 2, and we know that this value is e to the power minus 1 and 2.5. So this is, I'm directly writing 2.5 into e to the power of minus 1. So this will be the value of at most 2, and this is 0.9196.